So imagine finding this vibrant, bustling 19th century neighborhood, but literally every single history book you open tells you it doesn't exist.
Right, like a total ghost town in the records.
Exactly. I want to welcome you to today's deep dive because we are heading to the Mangareva Islands in French Polynesia. It's the 1830s.
Ah, beautiful area.
It really is. It's this breathtaking volcanic archipelago right at the southeastern edge of the territory, surrounded by these incredibly vibrant lagoons.
Yeah.
But the landscape is undergoing this massive, sudden transformation because French Catholic missionaries have just shown up.
And they were on an absolute mission.
A literal mission, yeah.
Yeah, specifically a group known as the frères bâtisseurs, the lay builder brothers, and they brought all this European building expertise and just a super aggressive architectural agenda.
They really did.
Yeah.
They fundamentally changed the skyline of these islands in just a few years.
Completely. And the historical records they left behind are, honestly, they're meticulous.
Oh, they wrote everything down.
Right. They documented this massive cathedral they built in the main village, Rikitea. They kept all the receipts for churches on the neighboring islands, like Aukena and Akamaru.
Taravai, too, I think.
Yep, Taravai. They logged the schools, communal bread ovens, a weaving workshop, even this grand royal palace for the local chief, Maputeoa, after he converted.
And a massive coastal watchtower.
Exactly. So they wrote everything down when it came to their own grand European-style buildings.
Right. But here is the massive historical blind spot we are digging into today for you.
Yeah.
They deliberately erased the homes of the actual locals from that written record.
It's wild. The Polynesian converts that they were supposedly there to serve,
Yeah.
their daily lives, their homes, their routines, just completely left out of the official missionary diaries.
But the physical evidence refuses to be ignored. I mean, the ruins of those homes are still sitting right there on the islands today.
They're just sitting there, yeah.
Which brings us to the core mission of this deep dive. When colonial written records deliberately leave a specific group of people out, how do we force those silence walls to speak?
That's the big question. And to answer that, we're looking at this fascinating 2026 study.
Published in Antiquity, right?
Yeah, the journal Antiquité by James Flexner from the University of Sydney, along with his team's really detailed research notes.
And the sources focus on 69 surviving ruined stone cottages across 4 of the Mangareva Islands.
Yeah, the local term for them is arpotu.
Yep.
And they aren't just like a minor footnote.
No, not at all.
They actually account for more than half of all the colonial-era structures archaeologists have found out there.
More than half. And more importantly, today we are going to look at a groundbreaking new scientific dating method that is finally giving these forgotten homes their rightful place in history.
Right, because to understand why these cottages have been such a headache to study, you have to look at how they were actually built.
Yeah.
So the Polynesian converts learned European masonry from the missionaries, but they used local materials.
So no imported bricks.
Right, no bricks. They built the walls using blocks cut from Acropora branch coral, which they harvested right from the nearshore reefs.
And some shoreward beach rock, too, right?
Exactly. And historically, we just kind of broadly knew that this coral wall construction boom happened somewhere between the 1830s and the 1860s.
Before they transitioned to timber in the 1870s. Okay, let's unpack this. Because if you know the rough 40-year window and the ruins are literally standing right in front of you, why has it been such a massive scientific headache to just figure out exactly when a specific house was built?
It's incredibly frustrating for archaeologists.
Because, I mean, isn't radiocarbon dating the undisputed gold standard? Why can't we just calibrate it differently for the 1800s? Like, why throw the whole method out?
Well, the thing is, radiocarbon dating is brilliant for ancient history, like thousands of years ago. Perfect.
Right.
But it hits a total wall, or, well, technically a plateau when you get to the last few hundred years.
A plateau.
Yeah, the radiocarbon curve for the 18th and 19th centuries is notoriously flat. It's really erratic.
He's the Industrial Revolution.
Actually, even before the Industrial Revolution and atomic bomb testing totally messed up the atmosphere's carbon isotopes.
Oh, really?
Yeah, just the natural fluctuations in carbon-14 during the 1800s mean that if you test a single sample, it could mathematically return a date of 1810, 1850, or 1900.
With equal probability.
With exactly equal probability.
Wow. So using radiocarbon dating to figure out if a house was built in the 1840s is basically like using a giant highway milestone to measure a millimeter.
That is exactly what it's like.
It's just fundamentally the wrong tool for the job.
Yeah, the margin of error makes it completely useless for this kind of microhistory.
So what do archaeologists usually do when radiocarbon fails?
Usually they pivot to something called artifact proxy dating.
Okay, what's that?
It basically means looking at the trash left behind. Like if you find imported European ceramics, clay pipes, or, glassware.
Oh, I see. Because you can look up the manufacturing dates for those specific items back in Europe.
Right. If you dig up a plate that was only ever manufactured in some factory in France between, say, 1840 and 1850.
Then you know the house was occupied roughly around that.
Exactly. But the operative word there is roughly.
Right.
Because proxy dating requires highly disruptive physical excavation. You have to tear up the site to find the trash.
Nobody wants to destroy the ruin to save it.
Exactly. And beyond that, it introduces so much interpretive noise. I mean, think about the logistics in the 1840s.
Yeah, the shipping times alone.
Right. How long did it take for that plate to travel on a ship all the way from Europe to French Polynesia?
Months, at least.
Did it sit in a warehouse in Tahiti for 5 years? How long did a family carefully use it before it finally broke and was thrown in the dirt?
Oh, that's true. An heirloom could be 50 years old before it becomes trash.
Exactly. So proxy dating only narrows things down to these big multi-decade spans. And crucially, it doesn't actually tell you when the walls themselves were raised.
Right, just when someone was eating dinner there.
Exactly.
So if standard archaeology is too blunt and digging up plates is too noisy, how do we force these silent coral walls to talk?
Well, researchers had to look at the unique chemistry of the building material itself. The coral.
And this study introduces a true game changer, right? Uranium-thorium dating.
Yes. Uranium and thorium, or youth dating. Flexner's team actually had their samples analyzed at the University of Queensland Radiogenic Isotope Facility.
Okay, I know we're getting into the heavy science here, but explain the mechanics for us. What exactly makes this chemical clock tick?
It relies on this beautiful quirk of ocean chemistry involving solubility.
Okay.
So as living coral grows in the ocean, its calcium carbonate skeleton naturally absorbs trace amounts of elements from the surrounding seawater.
Like a sponge.
Right. And uranium is highly soluble in seawater. It dissolves really easily.
Okay.
So the living coral drinks it right up and incorporates the uranium directly into its skeleton.
But it doesn't absorb thorium. Why is that?
Because thorium is completely insoluble in seawater.
It just doesn't dissolve at all.
Nope, it doesn't dissolve. It either sinks to the bottom or binds to floating particles, which means the concentration of thorium in ocean water is practically zero.
Wow.
Therefore, a fresh, living piece of coral will contain measurable amounts of uranium, but absolutely zero thorium.
It's literally like an hourglass that is entirely full in the top half with absolutely nothing in the bottom half.
That is the perfect analogy. And the moment the coral dies...
Whether it washes ashore or gets cut out of the reef by a builder.
Exactly. The moment it dies, it stops interacting with the ocean. It stops taking in new uranium.
Right.
And the uranium that is already trapped inside its skeleton is radioactive.
Oh, so it decays.
Yes. It slowly, steadily decays into thorium at a strictly known mathematical rate.
So the sand starts falling through the hourglass. The uranium turns into thorium over time. And because the coral started with zero thorium on day one, all you have to do is measure the exact ratio of those two elements in a dead sample to know exactly how long it's been since the coral died.
You've got it perfectly. Under ultra-clean laboratory conditions, they use mass spectrometry to measure those isotopes.
And it's accurate?
It can give you a date accurate to within just a few years. It completely bypasses that whole radiocarbon plateau problem.
That is incredible. So Flexner's team sampled 10 branch corals directly from the limestone blocks of these ruined cottages.
Right. And what's fascinating here is if you're picturing a modern archaeological dig, you can erase that. They didn't have to bulldoze these ruins.
No tearing up the floorboards well, mostly.
Right. They specifically looked for unweathered or minimally weathered coral embedded right in the standing walls, and they just took these tiny core samples.
They are essentially reading the chemical time stored inside the rocks without destroying the architecture.
Precisely.
But did they know for sure this ocean chemistry trick would actually work on a 19th century building?
Well, they had to prove it first. They needed a control site.
Okay, where did they go?
They went to the boys' school at Aukena, the College de Aneotiki.
Because the missionaries wrote that one down.
Exactly. We know exactly when that was built because it's in their meticulous records between 1853 and 1858.
And the coral sample they pulled from that school returned a U-teeth date of 1831 plus or minus 2 years.
Which is incredibly close. It totally proves the chemical clock works.
Wait, 1831. But the school was built in the 1850s.
Right. And as you can probably deduce, an 1831 death date for a coral block used in an 1850s building introduces a massive logistical headache for historians.
Because dating the rock doesn't actually mean you are dating the house. You're just dating the moment the rock died.
Exactly. The uranium-thorium method tells you when the coral ceased to be a living organism.
It doesn't tell you when a Polynesian builder actually picked up that piece of coral, squared it off, and placed it into a mortar wall.
Bingo.
I mean, if builders waded out into the lagoon and cut fresh coral from the living seaward edge of a reef, the coral dies the day it's harvested.
Right, and in that specific scenario, the death date of the coral and the construction date of the house are identical.
But you're telling me they didn't just harvest fresh reef?
No, they frequently gathered material from the shoreward limestone and, the beach rock formations. And in those environments, the coral might have naturally died and washed up years or even decades before a builder ever came along to quarry it.
That explains the boys' school dating to 1831, even though it was built in the 1850s. They just used beach rock that had already been dead for 2 decades.
Exactly.
But our sources mention it gets even more complicated than just picking up old beach rock.
Oh, it gets much more complicated.
Yeah, some of the dates came back way older. When they sampled the massive watchtower, the date came back to 1786, plus or minus 5 years. And one of the Polynesian cottages, a house designated AKH 11, returned a date of 1779. Both of those dates are half a century before the Catholic missionaries even set foot in Mangareva.
And this is where the chemistry reveals a really profound cultural shift.
How so?
Well, the archaeological literature, which is heavily informed by research done back in 1939 by K.P. Emery, that research has long suggested that pre-contact sacred temples known in Polynesia as marae were cannibalized for building material during this 19th century missionary construction boom.
Whoa. So the converts were taking down their own ancient sacred sites, dismantling the architecture of their previous belief system to build these new Catholic cottages.
The data strongly supports that, yeah. Now, the study notes this reuse was modest.
Right.
Like, there was no evidence of large-scale industrial looting of ancient, centuries-old reef formations, but recycling older sacred stones absolutely happened.
That's amazing.
And for an archaeologist, this creates a concept known as a terminus post quem.
The limit after which.
Right. It's basically the coral equivalent of the old wood problem in dating historical timber buildings.
Oh, like if a tree is chopped down in 1800.
Right. A tree is cut in 1800, but a farmer might recycle those exact barn planks to build a brand new house in 1850.
And if you date the wood, you get 1800, not 1850.
Exactly. The use date of the coral simply establishes the earliest possible moment of construction. The building can only be the same age as the coral, or younger.
Here's where it gets really interesting, though. Wait, if a builder recycles a sacred temple stone to build a Catholic cottage, the scientific date we get is actually the date of the ancient temple, not the new house.
Right.
So how do we ever get a true story out of that? If the dates could be off by decades because of recycled stones or old beach rock, how do researchers bridge that gap to zero in on the actual people living in these unrecognized homes?
To bridge that gap, the researchers needed a site where the chemistry, the architecture, and the human garbage all collided perfectly.
And they found one.
They did. Which brings us to one specific cottage in the study. A house labeled AKH 20 on the island of Akamaru. Honestly, this is the Rosetta Stone of the whole project.
Okay, so paint the picture for us.
So the team takes a coral block right from the standing wall of AKH 20. They run it through the mass spectrometer, and the uranium-thorium date comes back at 1846 plus or minus 2 years.
Right in the thick of the missionary period.
Exactly. Then the excavators opened a small test unit directly under the floorboards in the southwest corner of the house.
And buried beneath the floor, they discovered a pit, designated PN 318 in the study.
Right. And if you're picturing like a little divot in the dirt, think bigger.
Yeah, this pit was filled with an unusually dense, heavy concentration of debris. We're talking animal bone fragments, shells, shattered glass, iron artifacts.
And crucially, debris heavily related to alcohol consumption.
Right. Now imagine you're a builder or a family living in the humid tropics.
Oh, it'd be awful.
Having a giant open garbage pit full of rotting food, animal bones, and broken glass right inside your small household, directly under your living room floor, makes absolutely no sense.
None at all. It would be entirely unsanitary.
And just completely impractical for daily life.
It wouldn't happen, which led the researchers to a really brilliant deduction.
Which was?
This pit wasn't just a slow accumulation of daily household trash over years of living. This pit brackets a single, isolated, massive historical event.
And the chemistry actually proves it.
Yes, because mixed directly into that dense debris of bone and glass inside the pit, they found a trimmed branch of coral.
Like a scrap piece.
Exactly. It was clearly a piece of scrap cut away during the construction of the house. So they ran Youth-Date in on that specific scrap from the pit, and it came back at 1848, plus or minus 4 years.
Wow. The date of the main wall block and the date of the coral scrap in the garbage pit overlap perfectly.
Perfectly. What you are looking at is a frozen moment in time from roughly 1848.
So what's the scene? What happened that day?
Well, the builders are on site. They are cutting, squaring, and shaping the coral blocks to raise the walls of AKH-20. The trimmings and scraps of coral are falling onto the dirt.
Okay.
At the exact same time, they're having a massive feast, almost certainly a celebration of the construction itself.
Like a foundation laying party.
Exactly. They finish the feast, sweep all the debris, the bones, the bottles, the coral trimmings into a pit, build the floor right over it, and seal it.
It is a stunningly vivid image. You have the older Polynesian traditions of feasting, community gathering, and foundation laying happening simultaneously with the adoption of European Catholic domestic routines.
Right, which we see through the imported European glassware and cooking pots found embedded in the walls.
It's just this profound synthesis of cultures. The missionaries were teaching them European masonry and Catholic dogma, but the Polynesians were adapting it, right? Retaining continuous ties to older ways of celebrating and living.
Completely. And let's not forget the ultimate irony of AKH-20. This incredibly vibrant human event, this beautiful community celebration of a new home, is completely and utterly absent from the missionary diaries.
Wow.
The missionaries didn't deem it important enough to write down, but the Polynesians literally buried the chemical and physical proof of their joy under the floorboards of the very houses the missionaries taught them to build.
That is amazing.
If we connect this to the bigger picture, it illustrates perfectly why relying solely on colonial records gives us an inherently fractured, biased view of the past.
Because the documentary record only tells you what the person holding the pen wanted you to know.
Exactly. But the physical, chemical, and archaeological records hold the unspoken truths.
So we've solved the mystery of one house, AKH-20, on one island. But how does this technique scale? I mean, you might be wondering, does this just apply to French Polynesia?
Not at all. The implications are completely global. Coral limestone buildings survive all over the world.
Really? Where else?
You see this architecture across the Caribbean, along the East African coast, throughout the Torres Strait Islands.
Oh, wow.
In all of those places, you have colonial-era architecture built by colonized populations whose daily lives, much like the Mangarevans, were deemed unimportant by European record keepers.
So what does this all mean?
By using uranium-thorium dating, we can bypass those written blind spots entirely. We can finally map out which household appeared first, how undocumented social patterns evolved, and tell the stories of builders all over the globe just by reading the chemistry of their walls.
The sources highlight one more incredible angle to this study, and honestly, it might be the biggest revelation of all.
Oh, the climate data.
Yes. These 69 coral cottages aren't just cultural diaries, they're literally climate time capsules.
This is an extraordinary secondary benefit of the research, and it brings the story right into the 21st century.
Because today, when we think of coral reefs, the conversation is always dominated by modern bleaching events, ocean acidification, severe climate change.
Right. But remember the mechanism we discussed earlier, how the coral absorbs the chemistry of the seawater while it's alive to get its uranium.
It doesn't just absorb uranium. It's a sponge for literally everything in the water at that exact moment in history.
Exactly. Each block of coral used in these 19th century homes is a high-definition historical archive of the pristine, pre-industrial reef environment.
That is so cool.
Scientists can extract far more than just age from these blocks. By analyzing isotopes of oxygen and carbon trapped in the coral skeleton, climatologists can determine the exact sea surface temperatures and rainfall patterns of the 1830s.
Wait, how does oxygen tell you the temperature?
Because the ratio of oxygen 18 to oxygen 16 in the coral changes depending on how warm the water was when the coral was actually growing.
Oh, that's brilliant.
Precisely. Furthermore, they can look at trace metals. Strontium to calcium ratios provide secondary temperature data.
And barium levels can show how much river runoff and sediment was flowing into the lagoon, right?
Yes, exactly. They can even measure heavy metals to establish baseline pollution levels from before global industrialization completely altered the oceans.
So marine biologists and ecologists don't have to guess what a healthy Pacific reef looked like 200 years ago.
No guessing required.
They can literally walk up to the wall of a Polynesian cottage, take a core sample from a stone, and read the exact temperature, salinity, and chemical makeup of the ocean from the year 1845.
The houses are quite literally a bridge between human history and environmental history.
It totally elevates these ruins from regional archaeological curiosities to, like, vital global climate data banks.
They contain the baselines we desperately need to understand exactly how much our modern oceans have changed.
Think about the journey we've just taken. We started with a deliberate colonial blind spot, the omission of Polynesian converts from the historical record by the French Catholic missionaries.
Right.
We saw how traditional archaeology like radiocarbon dating was simply too blunt, like a highway milestone measuring a millimeter. It couldn't read the tight timelines of the mid-1800s.
And then we explored that elegant quirk of ocean chemistry, uranium dissolving in seawater while thorium doesn't.
Turning dead coral into a highly precise radioactive hourglass.
And we saw how researchers navigated the old wood problem of recycled sacred temples to find a frozen moment in time.
Culminating in that incredibly cinematic scene at House AKH 20, a sealed feasting pit, capturing a single day of celebration, construction, and cultural blending hidden right beneath the floorboards.
It really proves that even when history tries to ignore a group of people, they leave an undeniable trace written in the very stones of their homes.
It does. Which leaves me with a thought I can't quite shake, and I want you to think about this too as you go about your day.
Okay.
We just saw how 19th century Polynesian builders inadvertently captured the pristine, pre-industrial state of the world's oceans simply by building their homes out of local coral. Every wall became an accidental environmental archive. Think about the home you are sitting in right now. What chemical legacy are our homes capturing? Hundreds of years from now, when archaeologists use whatever futuristic tools they have to test the synthetic materials, the drywall, the modern insulation, and the microplastics embedded in our current houses. What exact environmental story will our walls tell about the 21st century?
That's a powerful thought. We're all leaving a record, whether we intend to or not. The architecture always absorbs the era.
It really does. Thank you for joining us on this deep dive. Keep questioning the narratives you're given, keep looking for the hidden stories, and as always, keep exploring the world around you.